Determine voltage V using nodal analysis. V is this, which is the drop across 2 ohm. So it's nothing but you have to find nodal voltage V2. So there are three nodes V1, V2, V3 is a reference node. We can solve using nodal analysis. So applying KVL here, this V is nothing but nodal voltage V2 only, and this node directly connected to this with the voltage value of 3 volts. So we can directly tell that from the figure nodal voltage V3 is equal to plus minus, it is 3 volts only. So this is correct. Apply KCL at node 1. This current plus this, all the currents are going away from the node, you have to consider. Node 2 also, the currents going away from this. For this we cannot apply KCL because this we know, this current we know, this we don't know, because resistance of this voltage source we don't know. So we cannot apply KCL for node 3, but we can tell that directly V3 is equal to 3 volts. So from this V1 minus V3 upward currents, V1 minus V3 by 3, V1 minus V2 by 1, and minus 2. This is coming down now. Minus 2 is equal to 0. V1 minus V3 by 3, V1 minus V2 by 1, minus 2 is equal to 0. This minus 2, if you bring it to right side, you get the same equation as this. And if you simplify this, you will get equation number 1. Similarly, apply KCL at node 2. Apply KCL at node 2. Left side current is V2 minus V1 by 1, V2 minus 0 by 2, V2 minus V3 by 4 is equal to 0. Again, if you simplify this, you will get another equation. And solve these two equations using calculator, we will get V1 is equal to this, V2 is equal to that. In the problem, they ask to find V2. V2 or V is nothing but V2, the given diagram. They ask to find V here. This V is nothing but your V. So what V2 we got? 3 volts. So 3 volts is the answer. Next, sometimes they'll ask, this is also some tricky question. Find V1, V2, 3 using nodal analysis method. Please observe here, normally they will give 2 ohms, but here they are given mho. Mho means it is conductance. 2 mho is equal to 1 over 2 ohms. Okay. So here also you have to apply KCL. And if you are applying KCL, uh, this is the first current, second current. Here I cannot apply KCL for this because there is a voltage source. Can I apply for this V2? Left side current I can write. This also I can write. This also I can write. For this one, this and this and this. But here I cannot. I don't know the resistance of this 2 volt source. So I cannot apply KCL for node 1, node 3. So solution is what? You have to form a super node by combining these two. By combining these two, I can apply super node. Super node, if there is a voltage source present between two nodes, ideal voltage source present between these two nodes, I can combine those two nodes and form a super node and directly write one equation. Plus is towards V3. So V3 minus V1. V3 minus V1 is equal to 2 volts. The equation number 1. Now apply KCL for super node. So from the super node, these two currents and here these two currents all belongs to this V1 nodes and V3 nodes currents. So two currents this side, two currents this side, you have to write. So first current is V1 minus V2 by 3. Actually V1 minus V2, you see it is in mho. In mho means it is 1 by 2 ohms. Similarly, it is 4 ohm is 4 mho is divided by 1 by 4 ohms. Okay. So here I'll applying KCL for this one. 2 V1 minus 0. So V1 minus 0, V1 V1 minus 0 by 1 over 2 ohms. Okay, mho means 1 by 2. So it is nothing but this 2 will come to here numerator. So 2V1. Similarly, V1 minus V2 by 1 by 3. V1 minus V2 by 1 by 3 is 3 will come to numerator. V3 by 1 by 4. V3 by V3 by 1 by 4, that 4 will come to numerator. V3 minus V2 by 1 by V3 minus V2 by 1 by 2, the 2 will come to numerator. That is the difference between mho. You have to observe properly how they are given. This is a mho symbol conductance value. If they give ohm, if they give 2 ohm, then you have to write in denominator. If they give in conductance, it will come to the numerator. So simplifying this, you will get this equation. Similarly, apply KCL at node 2. Okay. One equation is V3 minus V2 is equal to this voltage value of 2 volts. Three equations are required. One equation is directly from this super node. Second is obtaining from writing KCL for the super node. Third one is you can apply KCL for this left side current, downside, and this left side current is V2 minus V1 by V2 minus V1 by 1 by 3. That is 3 will come to numerator. And the next is right side is V2 minus V3. V2 minus V3 by 1 by 2. So better you write all you write like this 1 by 2 ohms, 1 by 3 ohms, 1 by 2 ohms, 1 by 4 ohms, like that. Then you will not get any confusion. And this is minus, this is down, but current going opposite now. So it is minus 1 amp. If you bring it to right side, it becomes plus 1. I'll write here if you want to neatly. If you write KCL at node, you will get like this. 3 will go to here. This 2 will go to here. Minus 1. If you bring it to right side, you will get this equation. So you will get equation number 2 and equation number 3 is equation number 1. Solve these three equations by writing in the matrix form. You will get first equation. It is V1 minus V3. V minus V1 plus V3 is equal to, so minus V1 0 1. This is V1 V2 V3 is equal to 2. Next 5V1 minus 5V2, 6V3 is equal to 0, minus 3 plus 5 minus 2 is equal to 1. This is equation is 3 unknown variables. Minus 1, 0 is equal to 1 is equal to 2 is equal to 5 minus 5, 6 is equal to 0 is equal to minus 3, 5 minus 2 is equal to 1. To simplify this, you will get x as minus 1.16 minus 0.16 0.83 with the same answer. So these answers are correct.